All right, what's on the bench today? It's an old Hewlett-Packard Harrison power supply, a 6299A. It's a 0 to 100 volts, so that's fairly rare. 0 to 0.75 amps, so pretty heavy duty. But 0 to 100 volts, that's interesting. Oh, yeah, just going to use a little bit of oil. But yeah, 10 turn pot on the voltage, 1 turn pot on the current with a fine. It's got a broken knob. I probably have a replacement knob. It's got a crack on it. The meter is 12 volt, 120 volt, and then 0.9 amps and 0.09 amps. Okay. So where did I get this thing? Well, I was at Anchor Electronics the other day, and the owner had sold this to somebody for $75, and they brought it back saying that it had a bad capacitor. And it was one of these computer grade capacitors, and it made me very suspicious because those things never go bad. I've seen super old ones. They just seem to never go bad. But we'll test it and see if the guy was right. Let's take a look inside. It's already been opened up. He did keep all the screws and everything, so that was good. There is a very dark picture. All right, let's see here. Okay, so here's the thing to point with here. Pretty standard layout for these things. There's 2 big pass transistors here and here, big giant heat sink. This capacitor used to live up there. Now there's a capacitor here that looks like it's on a bodge wire. And there's a standoff here that looks like it's a bodge. And there is a wire that goes to nowhere with some heat shrink on it. So, my guess is this is complete bodge and part of the troubleshooting. But I'm not quite sure of that. I've not seen this particular feature before working on these supplies. There's 4 potentiometers here, and you can reach through these holes here to adjust them, and that's unusual. Usually they're on the board, and you have to tweak the board. I don't know if there's cutouts in the actual. Yeah, there is. Let me see that. Just a second here. Oh yeah. So there's a sticker here that's been ripped off, and it says voltage. I'll have to make a new sticker. Voltage program 0 and current program in 0. Yeah, so that's an interesting feature there. Let's see if we can't find anything else that's suspicious inside this thing. All original caps, Sprague. Funny cap here. Really fancy resistors. Those pretty penny back in the day. Probably even a prettier penny today if you can't find them. Yeah. Now he Gus didn't trust himself. He marked with a big Sharpie here and a big arrow here. When on the PC board, it's obviously marked with a minus and a plus. So I don't know. Go figure. So I'll see if I can clean that up and make it look a little nicer. Another original cap back there. So anyway, it looks all original except for this really funny bodge here. But the bodge, the capacitor used looks vintage. So yeah, I'm not quite sure about that. We'll have to get out the service manual for this thing to try to figure things out. But he had taken this out, didn't bother putting it back in, and once again he can't see that, can you? Once again he put a big thing on here, arrow. The capacitor is marked very clearly plus sign on it, so I don't know why he's going through all this trouble. The board is marked clearly and the capacitor is marked clearly, so Yeah, that makes me suspicion on his capabilities and these types of things. There's a little bit of discoloration here. Let's see, it did sit in like that. Could just be heating from the transformer, just discolored that a little bit. Nice beefy transformer. But yeah, let's test this thing. It claims to be a, I think, 710 microfarad at 200 volts. So let's see if we can clip these on here and see what it says. Can you see that? There we go. 925 microfarads. That's good to me. What's the ESR measuring? 0.09 ohms. I say that's a good. That's a good cap. So, if you want to know the difference between this meter and one of those in-circuit meters that measures the ESR correctly and everything, well, first of all, you can do the 100 kilohertz measurement, which is the standard, and it's measuring 0.09 ohms at 100 kilohertz. The one thing this doesn't have is the glue-on chart. So, so print yourself out a chart, and then you're set to go. Can you read that? Or is that kind of blowing out there? Let me change the. Oops. Let me change the camera here. There we go. You can probably read a little bit better. So we are what, 710, about 1,000, and we are 200 volts. So we're kind of up this away. And so we should be right around 0.1 ohms. And we are. So this capacitor tests out perfectly good, which I assumed it would. These things just never go bad. So let's assume he doesn't know what he's talking about. And we will not have any preconceived notions of this thing. We will just go at it like we found it in the trash can. All right. Well, I decided to go ahead and power that thing up, and it immediately blew a fuse. So I put in another slow blow fuse, and I heard high voltage arcing sounds. So I turned it off, and I put it on a variac, and I slowly increased the voltage, and I was getting zappy sounds. So something's breaking down, and I'm going to use some of the information that I was given, which was I have a bad capacitor. And I was thinking, well, could the capacitor be bad at high voltage but good at low voltage? And I suppose that could be a thing. So let's do a couple things here first. Let me, I'm going to use my, my discharging tool here. And you can see the LED lit up there, so it's good that I'm discharging it. So I'm discharging my capacitor, and it's pretty healthy, right? It's a 200 volt capacitor, and I think in circuit it takes 150 volts, so it could be high. So it's now discharged. And now I can measure it. So I'm going to use my new ESR measuring tool, and we'll see if that says that the capacitor is okay. So we'll put this on. And this says it's 0.02 ohms. So this capacitor checker says that it's just fine. All right. Now this tests at something like 200 millivolts or something, right? So let's go ahead and use some old school stuff. I have this capacitor checker, which can go up to 500 volts. So let's go ahead and test this capacitor at voltage. First we'll test it at very low voltage and see what happens. So we'll put the clip leads on it, and let's see, I need to prop this up so you guys can see it. I guess that's okay. All right, so it is balancing out around 700 microfarads. Let's see here if I can put in some. Yeah, Yeah, around 680 microfarads, something like that. So it's testing out just fine. All right. So let's go ahead and, so that was with no charge on the output. You can adjust the voltage here. So I can adjust our test voltage here to 200 volts, which is what this capacitor is rated at. And then when I move this knob over to the capacitor charge, it will take it up to the 200 volts, okay? You can watch it charge up here. Oh, you hear that? It arced. It arced again. So, this capacitor has a high voltage path in it. So it wouldn't have been caught on any other type of test equipment except for this thing, which can do it at voltage. So that is really, really interesting. I'm going to discharge this thing again, yeah, so I don't kill myself. All right, so I take it all back. The old timer who had this before me knew what he was talking about. This capacitor is bad, but for a weird reason. It arcs at high voltage. Yeah, very strange. Never seen that before. So I need to find myself a 700 microfarad, 200 volt capacitor, and be nice if it fit in the same package. So I'll have to go online and search for that. I think I remember saying that, asking at the store, did you have a new one of these? And they said no. They do have a selection of these though on their. They have some old one of these on a shelf in their store. I may go look there as well, but I'll go online if I can't find one. They're probably fairly expensive. I'm imagining this is maybe, I don't know, $25, $30, something like that. So yeah, let's go off to the computer here and see what's going on. But yeah, that's a new one for me.